Okay, well, with that fun little preamble, hi y'all. My name is Michael Chiappone, and I'm really excited to talk to y'all today a little bit about a topic that a lot of people don't think about quite as much when they're doing paleoart, and that's the geology side of paleontology. I know that a lot of people, when doing paleoart, see the word landscape and freak out a little because they can be really complex and a little difficult to reconstruct. But I'm hoping that today I can convince you that not only are landscapes really interesting and fun to reconstruct, but they're also really important to our understanding of the fossil record. So like I said, my name is Michael Chiappone. I'm a paleontology PhD student, second year at the University of Minnesota. I also do some science outreach and occasionally paleoart myself. My research is focused on fluvial taxonomy of fossil vertebrate bones, but that won't matter so much today. Because what really matters is that I have an undergrad degree in geology at UT Austin, and my current degree is in geology, PhD-wise, and thus I have a passion for cool rocks. So I'm hoping that today I can convince you that the geology side of paleontology really is just as important as the biology side, where we're trying to reconstruct ancient ecosystems. So we're going to start from the basics and move up. So the two main rock types that are really important to us right now for paleoart reconstruction are sedimentary on the right there. These are rocks that are formed by deposition of weathered rocks and organic material, and igneous, rocks that are born of heating and cooling of magma. Metamorphic is also there. We won't worry so much about that for now. But those are the two main sources of rocks that we're going to gather information from as we go forward. Okay, well, how are these rocks organized in the wild, so to speak? Rocks of similar ages can essentially be grouped together on different levels, big or small, to create what you read in the literature as members and formations and groups and supergroups and all that fun stuff. However, it's really important to note that these are not standard in time or space. Something like a formation, a geological formation, can be giant or tiny, both in terms of time and in terms of space. Ideally, these represent clearly discrete time intervals with a coherent and identifiable lithology over a lateral area, meaning you can clearly identify what is, say, Morrison Formation versus what is not. And speaking of formations, that's a word you've probably heard a lot. What is a formation? A formation is essentially a succession of similar depositional environments, we'll get to what that is, over a set amount of time. I.e., this is not necessarily one continuous ecosystem. This is through time. Fauna can vary throughout these. Not all formations also represent the same length of time. Like I mentioned, some can be very short, some can be very long. The Cedar Mountain Formation, for example, is incredibly long compared to many other formations. Like I said, they can also take up wildly different spatial areas. For instance, the Morrison Formation is huge, whereas others are not quite so big. Depositional environments can also vary within formations across space and time. The Candelaris Formation, where Giganotosaurus is found, also has a really distinct Aeolian dune sea section as compared to the more fluvial stuff where that animal was originally found. So let's talk about depositional environments. This is where the magic in terms of sedimentation actually happens. So what exactly is a depositional environment? Because it's not quite the same as an ecological habitat. All a depositional environment is an environment in which sediments can accumulate. There's a lot of examples of those on the right there, on the top right, from fluvial stuff all the way out to the ocean. But this is in reference to a style of sediment deposition, not an ecological habitat. This is a really important distinction. When you read floodplain in the literature, this is why they use floodplain so much. Floodplain can mean a lot of different things ecologically, but depositionally, it really means one thing. It means the area around rivers. And we interpret depositional environments, how do we know what these are? The way we do that in the geologic record is by looking at a variety of geologic characteristics of rocks. So, for instance, lithology. What is the rock made of? What minerals does it have in it? What grain sizes are the rocks made of? Like if it's sandstone, is it coarse? Is it fine? Is it silty? Is it muddy? What sedimentary structures does it have in it? Are there ripples or dunes or mud cracks or different things that can give us hints to how this deposition happened and what happened to it after deposition? How does it vary laterally across an outcrop or across an entire larger area? And finally, stratigraphic context can tell you how all of these things fit into a larger temporal, i.e. time-based context. And you can see kind of an example of walking through that kind of thing in an outcrop on the bottom right there, looking at different aspects of this outcrop to suggest that it was a tidally dominated sandy beach. So the existence of the fossil record depends on where and how sediment is deposited across the surface of our planet. Multiple depositional environments can be preserved spatially nearby to each other, and temporally you can have them stacking on each other vertically. These may or may not represent the areas where organisms are living, and as such, paleoart often, but doesn't always, take place in the depositional environments where animals are found. For instance, finding terrestrial animals in lakes and lagoons that we know they weren't living in, but that's where they were deposited. They lived in the areas around the lagoons. And you can see an example of how much different depositional environments contribute to fossil bone beds in the fossil record, with alluvial really overtaking all of the rest of them. It's why floodplain is so common in the fossil record. And I want to run you through a little bit of a very quick exercise given the time. So, looking at this image that I took from atop a big steel structure on the Texas coast, how many different depositional environments do you think you can see here? Go ahead and think about it for a second and put your answer in the chat. I'll give you 5 seconds here just to think about it. Think of a number and put it in the chat. Okay. So, it's more than you think. Up close to us, we have a coastal wetland here, which way in the future could potentially be represented by organic-rich mudstones and coals. Further away, there's a tidal coastline over here where you could get, sandstones and siltstones with ripples and crossbedding. Further out, there's a little lagoon right there. That could be some low-energy silts and muds, maybe with some bioturbation, maybe even with potential anoxic conditions. And then way out in the back there, that's the ocean. That's the Gulf of Mexico. And so that's going to be your shallow marine stuff. You're going to have maybe carbonates out there, limestones, and reworked coastal siliciclastics like siltstones and sandstones and shales. So even just in this one image, you can really see a lot of depositional environments that you could represent in paleoart. So some quick tips based on depositional environments for you all. Consider when you're doing art, what depositional environments were present in the geological formations you want to depict, and how those interacted to create what we think of as habitats. These are all habitats in a way, but the way we define them is really based on deposition. So you got to think about it from that perspective. Take a more holistic view of all the environments present around where fossils are found when you're trying to consider how the background of your piece should look. What typical shapes do these tend to take based on how they form and all of that fun stuff. So, in terms of shapes, how are landscapes actually made? How do you go from just depositional environments to a landscape? Well, landscape creation is really driven by geomorphology. Geomorphology is essentially the forces that act to shape the landscapes that we walk on every day. And these are not static, but in constant evolution, even over really short time periods. You can see that almost all of the forces happening on the right there are happening over the course of decades. On the one on the top right, that's like a day of sand movement. And so some of the major processes that can work to shape landscapes include things like fluvial river action and avulsion and movement, aeolian stuff, i.e. wind-driven dune migration and wind-blown sand, tidal stuff where you can have coastal erosion and creation of sand beaches, and glacial movements where you can have glaciers dumping ice out the front side or retreating to reveal the formation of moraines and things like that in glacial till. And of course, there's many more that I could really go over, but there's a lot of different forces that you have to think about depending on the environments you're trying to depict. And these can happen on huge and on tiny scales. This could be the development or erosion of sand dunes along just one small section of coastline, or the deposition of the largest delta ever in the world's history. You can see that on the right there. Up in the Arctic Ocean, you get this massive deposit of delta sediment from the Triassic that is quite literally the biggest one ever found. And so some geomorphological tips for y'all. Put intention into your landscapes. Use geomorphology, how landscapes are shaped, to really think about environmental storytelling. What processes led to the creation of the area that your piece is set in? Why does it look the way it does? And how do organisms interact with those processes, over large and small scales? And how can those inspire pieces to begin with? There's a lot of really interesting ways you can come at this from, and I've included some examples at the bottom here from Doug Henderson and John Friesen, who both do incredible jobs at environmental storytelling. All right, but now we've gotten through a lot of the sedimentary stuff, and of course, all of this is going to be a bit of a sprint just because of how much there is to cover and how little time we have together. But I do want to hit on the igneous a little bit. Sedimentary is really what drives the vast majority of landscapes across our planet, but igneous has some really interesting presence in the fossil record and in historic paleoart, but also is just really important to our understanding of the fossil record. So we're going to do a little bit of an igneous highlight reel. So let's look a little bit at how volcanics have been treated in paleoart up to now. Volcanics are kind of a staple of classic paleoart, but often, like in that bottom left image or the one in the background of the slide, they're often depicted as just sort of generic cinder cones in the backgrounds of pieces where the organisms are supposed to take precedence. They're sort of treated as symbols of the world when it was still young, kind of a deal, which can be a cool atmosphere, but there are actually many legitimate reasons to depict volcanoes in paleoart, because their influence is seen throughout the geologic record. They're everywhere. And they can occasionally preserve absolutely spectacular fossils like ashfall fossil bed on the top right in Nebraska, and even allow us to precisely date many fossil sites using zircons. And of course, there have been some people who've done excellent jobs doing, highlighting volcanic stuff. That Doug Henderson Myasora piece with the pyroclastic flow is just awesome. But there are legitimate reasons to really think about volcanics in paleoart. And I would argue that up to now, we've really only scratched the surface of the diversity of volcanic phenomena that happen today in the world of paleoart. Volcanics there's a reason there's a whole field associated with it. Volcanology is amazing, and there's a huge diversity of things that go on when magma from the mantle interacts with the crust and the surface of our planet. There are so many different kinds of eruptions, different things that you can draw inspiration from that I won't go into right now because there's not enough time to really hit all of these in a big way. But suffice it to say that volcanics are really, really diverse. And they do really interact with landscapes in major ways. They can add topography and structure via, what they leave behind, volcanic flows and tuffs and extinct volcanoes and all of that on the landscape. But also things like hydrothermal activity. It is a route of deposition. You can see all of that flowstone there in Yellowstone. It can also remove topography and structure. It can literally destroy older ecosystems and even topography, spurring a reset of ecological succession on the landscape. And, as cool as it is to depict very well-established ecosystems, it's also really interesting to think about cycles of destruction and rebirth on ancient landscapes and how those could be factored into paleoart. On the bottom right there, you can see this whole forest has been laid low by Mount St. Helens after it erupted. But things grow back really quickly. I believe this is in Hawaii on the bottom left there. But you can see these ferns growing through a Pohoihoi lava, this ropey lava flow that recently has been deposited. On top of that, volcanoes don't only create and destroy physical structures, but they also have big influences on landscapes. Andisols, volcanic soils created via the erosion of volcanic material, and also things like tuff and ash, are often extremely fertile. Around the world, people farm on andisols. They're extremely conducive to vegetative growth, and they can support large animal populations. There's a really famous wildebeest migration that moves past the Old Dueño Lengai volcano, which is also a carbonate volcano, which is really weird and interesting. And it allows them, with all of this vegetative growth, to really take advantage of all of that vegetation as they move through. And so volcanoes are a really important driver of life around them, and this would have been the case throughout deep time. So things to think about as you're thinking about volcanoes in deep time. They're not only a destructive force. However, they are volcanoes, so they are destructive, and they can not only be locally destructive, they can also be landscapes. Some volcanoes get massive. One of the most visible of these is the Valles Caldera in New Mexico. This is a volcano with a 24-kilometer wide caldera called a resurgent dome eruption. There were multiple of these over the Pleistocene. And they had 400 cubic kilometers of volcanic material deposited, with found as far north as Canada. And I could go on about how crazy these eruptions are, but suffice it to say, this is a really complex volcanic system that is enormous. And when you stand on one rim of the volcano, you can't see the other side. It's so big. I've been there myself. And all of that even pales into comparison with large igneous provinces, which you probably know the name of because they single-handedly shifted global climate and wiped clean thousands of square kilometers of landscapes, contributing to mass extinctions in the fossil record, and thus are important to depict in paleoart. So some quick tips for volcanic stuff. Really think about the volcanic history and mythologies of an area, and consider the wide range of volcanic morphologies present throughout the geologic record when you're thinking about volcanoes for paleoart. There's so many interesting visuals you can go for. Was volcanism a major player before, during, or even after you set your paleoart? And how can it inspire composition, and etc.? And so with that, I'm going to go ahead and wrap up. Again, obviously, feel free to ask me questions in the chat when I'm done, because there's so much to cover. But suffice it to say that ancient environments are really vital to understanding the function and evolution of extinct ecosystems. And thus, geology surrounding fossils provides invaluable context to our understanding of the fossil record. Putting all of these different characteristics together to make a holistic model, depositional models of landscapes that then you can translate into paleoart to think about how landscapes are constructed from the bottom up in order to make really interesting and engaging paleoart. Landscapes aren't just a background that needs to be filled. They can be full of just as much character and educationally important information as the major players inhabiting them when done well. And thus that makes that kind of paleoart really educationally important and really visually striking. And so with that, I'm going to go ahead and say thank you for exploring the geologic world with me, and I will open the floor to questions. Thanks, y'all.